The webcomic XKCD taught me everything I know about physics. XKCD proved that web cartoons can be simultaneously educational and informative. Lin Clark is our guest today, and she talks with us about Code Cartoons, a series of cartoons that explain Facebook's open source projects like Flux and Relay with the same elegance and creativity that XKCD exhibits. At the 2016 O'Reilly Fluent Conference, Lin Clark will be speaking about Code Cartoons and the technologies that have sprung up around React.js. We are giving away a free ticket to Fluent 2016, which is March 8th through 10th in San Francisco. And if you want to be entered in to win this free ticket, send us a tweet about your favorite episode of Software Engineering Daily. In today's episode, I talked to Lin Clark about why cartoons can be effective in communicating difficult concepts like Flux and Redux, and why Lin focused on React as the first set of technologies to cover with Code Cartoons. But first, a word from the sponsors that keep the lights on at Software Engineering Daily. Engineers love automation, and Wealthfront automates your investing. As a software engineer, there are certain processes that you want to execute no matter what, like integration tests during a build. You wouldn't execute integration tests manually. You would use a continuous integration tool like CodeShip or Jenkins to automate your integration tests. Wealthfront is a tool to automate investing. Just like a continuous integration tool runs your tests automatically, Wealthfront can reinvest your dividends automatically and perform tax loss harvesting automatically. To get your first $15,000 managed by Wealthfront for free, go to wealthfront.com/sedaily and get started with Wealthfront's layer of automation on top of your portfolio. Wealthfront.com/sedaily. Check it out. It would support Software Engineering Daily, and you will get $15,000 managed for free if you sign up. Automate your investing. Get back to the things that you can't automate, like writing code. Lin Clark is a senior developer tools engineer at Mozilla, and she's also the creator of Code Cartoons, a series of posts explaining concepts around programming using cartoons. Lin, welcome to Software Engineering Daily.
Thank you, and thank you for having me.
Absolutely. You write a series of cartoons explaining programming concepts called Code Cartoons, and this is on code-cartoons.com. So far, these cartoons all have to do with React and other Facebook technologies. Why did you start with the Facebook stack?
Well, I actually started the project. The idea for Code Cartoons actually came out of my involvement, my early involvement with the React community. I had been asked to speak at React Rally, and I went to speak there, and I just really enjoyed my time there. For me, a lot of times the programming communities I get involved with is kind of because I like the people and the way they think. And then I start looking into the code and I like the code. So I had been hanging out with a lot of the people that were working with React and working on React and wanted to dive in more. So I started learning about Flux. And once I started learning about Flux, I thought that the docs, they were clear once I understood what Flux actually did. I could understand what that diagram was showing me, but I actually had to really dig in before I understood it. And that's tough when you're a developer, having to actually fully learn something before you can see the use case and understand how it's different than other technologies and where the pros and cons are. So that's where I actually had the idea for Code Cartoons, was starting with Flux. And so once that one was very, very popular, I thought, this actually might be a technique. I drew the cartoon about Flux and I showed it to people, and people thought that it really explained it very well. And so I thought this might be a technique that works for other things. And so I started applying it to other things in React because that's what I was learning at the time.
Yeah, I think it's a very effective way of teaching. This is sort of like next level documentation, entertaining documentation, different ways of explaining things. I know when I learn a programming concept, I don't just go to the docs. I often go to YouTube videos or perhaps read a slide share, or something like Code Cartoons is certainly very compelling. And I read through your Code Cartoons. I found them really helpful. So what does it take to write an effective Code Cartoon?
Oh, it takes a lot of work. So I will watch a lot of the videos because those do tend to give you more of the comparison that you need with other technologies. I'll watch, a lot of presentations from conferences and stuff like that. I'll read the docs, I'll read the specs, and then I'll step through the code many, many times over. So for this Relay cartoon, I'm releasing a 4-part series on Relay. I probably stepped through Relay doing the same sequence of actions at least 100 times. So I know like every bit of the code now. So it's a good learning exercise for me. But then I have to spend a lot of time figuring out how to isolate the different parts, which comes first. And that takes a long time. So it is a very time intensive process, but I hope that by spending this time doing it myself and learning these things myself, that I actually significantly reduce the amount of time that other people have to spend being confused about the framework.
Absolutely. So let's start this conversation with Flux. At the O'Reilly Fluent Conference, you're going to be talking about data handling in React, and I think a good place to start with this discussion is Flux. Describe the canonical problem between models and views that exists in an architecture prior to Flux. Before we had Flux, how did we handle this model and view relationship?
Right. So Flux actually, it evolved side by side with React as a way of handling a specific problem that Facebook was seeing with the model and view setup that they had. I don't actually know if it was traditional MVC. The way they describe it, it sounds like it might not have been. But the models and views that they had models that were holding the data, pushing the data down to the views, which were rendering the data. Now that's pretty straightforward. So you could have, one model communicating to multiple views, one view getting data from multiple models. But that's all pretty straightforward. Then, of course, because the view is presenting this user interface to the user, the user would be feeding data back up to the model. The user would be entering things into the views, and that data would need to then get stored in the model. So the views are pushing data back up to the models. And sometimes you have models that are connected to other models. You update one, and it really means that you need to update data in a different model. So you had model-to-model communication too. And so the way I describe this is it's kind of like an epic game of ping pong. You have this ball bouncing all over the place, or an epic game of pong, rather. You have this ball bouncing all over the place. And it's really hard to figure out where this change is going to end up. All of the different things it's going to have to touch when you send this change back up to the models, where it's going to land and all of the things it's going to have changed.
So how does Flux solve this problem?
The way that Flux solves this problem is by creating what's called a unidirectional data flow. So you have a change that happens on the user interface. And instead of having your views know exactly what they need to change in the models, have this kind of coupling between the view and the model, the view just creates this object that represents whatever change happened. It might be something like message create. It will have a type that says exactly what this change is supposed to be, and then all of the data that goes along with that change. So if you're creating a message, it would be the title, the user that created it, the body, that kind of stuff. So it doesn't actually know where this data needs to go in the model, how this data needs to be changed on the model. It just knows that there's a change that happened. And it sends this object that represents this change off through what's called the dispatcher. It sends it to the dispatcher, and then the dispatcher will send it to the stores. Those are the things that hold the data.
So we'll go through these different components of the Flux architecture. You describe Flux in terms of a cast of characters. And in your code cartoons, these characters are drawn with a personification of the different responsibilities that they have. So The first character that you draw is the action creator. What are the responsibilities of the action creator?
So the action creator is the thing that creates that action object that I was talking about, this object that represents whatever change needs to happen. And so this action creator, I like to think of it as a telegraph operator. Basically, it knows when the view comes to it with a change that needs to happen. The view doesn't know what the format needs to be for the rest of the system to understand what's going on. But the action creator, kind of like a telegraph operator, it knows exactly how to put that message into a format that the rest of the system can understand.
What aspects of an application would we want to define as an action?
Basically, anytime you have a state change with Flux, it's really neat. Once you define all of your state changes, so any user interaction that will change the data that's in the app, if you define these all as actions, then it's really easy for a new developer who comes on your team to look at all of the actions. It basically creates a really clear API. You have an action for each single type of thing that can happen. So that is anytime you would have a change that the user could make or any other part of the system could make to the data, you want to have an action.
Definitely. So the next character that you describe is the dispatcher. And like you said, the dispatcher is comparable to a telephone operator at a phone switchboard. And you have some nice drawings of this. And I really encourage people to check out code-cartoons.com to see these depictions of the different characters involved in this Flux personification. So the dispatcher keeps this big registry of callbacks. Describe the interaction between the action creator and the dispatcher, and explain what the dispatcher needs to do.
Well, the action creator will go ahead and send off the message to the dispatcher, and the dispatcher really doesn't have to do too much. The dispatcher actually just has this list of all of the stores that need to be notified of any actions. And in other architectures, sometimes the dispatcher will know, okay, this set of stores will be notified when a particular type of action comes in. This other set will be notified if a different type of action comes in. That's not the case for Flux. In Flux, the dispatcher just knows, I need to notify all of these stores. And so it will just send out the notification or the action to each store. It'll do it synchronously. It won't send it all out, send it out to the stores all at once, because then you can have issues of, the same kinds of issues I was talking about with this Epic Pong game. So it will actually send this action out in sequence, and then the stores will be the ones that take it from there.
So, as you said, the next component in the chain is the store. How do you think about the store?
I think of the store as an over-controlling bureaucrat. This is one of the things that kind of sets Flux apart, is that a lot of the control is centralized in the store. So the store basically tells the rest of the system, you can't touch any of the data. The only way that you can make a change to the data is to go through the appropriate channels, to go through this action pipeline. Some other architectures will have setters on the stores so that, the view could come in and call a setter on the store and directly manipulate it. But the store is very no touchy, it really wants you to go through the official bureaucratic channel.
How should we think about the idea of a store relative to the idea of a database?
So the store, it doesn't actually necessarily, it doesn't actually store the data to disk or anything like that. It just is an in-memory store. When you start talking about databases, there isn't really a particular way in Flux to do that kind of data persistence. You can add it in, but there's no really specified way to do it. What Facebook has done since introducing the Flux architecture is actually build another system called Relay, which they use for a lot of their apps to manage that communication between the data that's in the browser and the data that's in the cloud in the database.
Absolutely. And we will get into Relay later on. But to continue talking about just Flux, when the state of the store has changed, it emits a change event. And this notifies the controller view that the state has changed. And the controller view you describe as like this middle manager between the store and the view. And the store then tells the controller view when the state has changed. And it collects the new state and it passes that updated state to all of the views that are under it. So with all of these different characters of the Flux architecture in mind, could you explain how they interact from a high level? Just explain the Flux architecture from a holistic perspective.
Well, sure. That's why people call it a unidirectional data flow, because as people might have been able to hear from the description, the change, it just goes around in a circle. It goes from the view. The view actually captures the change coming from the user. And then has it formatted by the action creator. The action creator sends it to the dispatcher. The dispatcher sends it to the store. And the store then updates the data, lets the view know that it is changed, and then the view is the one that renders it out. The view, doesn't make the change itself. It goes through this pipeline that's a circle. So that's why people call it a unidirectional data flow.
Perfect. So let's get into talking about Redux. Redux is an architecture that solves the same problems as Flux, plus some additional ones. And the first problem is that the code for stores can't be reloaded without wiping out the state. So in Flux, the store contains two things, the state change logic as well as the current state itself. What is the problem with keeping both of these things in the store?
So this kind of comes from the way that Dan Abramoff, the guy who wrote Redux, was approaching the problem. He wanted to be able to do something called hot module reloading. And what hot module reloading is this idea that when you make a change to your code, you can just hit save, and it doesn't even reload your browser. It just goes into the JavaScript and using WebSockets basically swaps out whatever you were saving, the object that you hit save on, and it just swaps it out rather than reloading your browser. And so the neat thing about that is that if you have any state changes, if you've actually gone through and have started trying to debug and have added a bunch of things to the state, then they're still in your browser. You can still be debugging in the same spot, even though you've made this change to your code. And so the issue, you could already do this with a lot of components, as long as the component, if you could do it with CSS, you could do it with a lot of parts of your code that didn't have state. But anytime you were working with an object, if you wanted to make a change to the store, which held on to the state, then you would be reloading that whole object. And so that would get rid of that state. So you'd have to, anytime you want to debug something in your store, you're going to have to go through a much longer process. So that is what Redux does, is it basically makes it so that your store doesn't hold on to any state. Well, your reducer is what it's called in Redux. The part of the code that has the logic doesn't hold on to any state. It just receives state. And the store, which you don't actually even code in Redux, the store is provided by the library itself. That holds on to the state and passes it to the reducer.
So you also describe this problem of state being rewritten with every action. So I mean, what are the trade-offs between rewriting the state with every action and the Redux solution, which is to copy each state whenever a change occurs?
So yes, we're getting into the concept of immutability here. So that's one of the things that Redux does push you towards, is having your state basically be immutable. And I saw a really interesting thing on Twitter this week. Somebody was teaching a student about immutability. And the way that this student described it was something that's mutable is basically like save. Something that is immutable is like save as, or save a copy. So the nice thing about having your state be immutable and creating a new object anytime the state is changed is that you can actually do this thing called time travel debugging. It means that you can, if you make a change in your application and it turns out that change, there's a bug somewhere in the transition when between the old state and the new state, you can actually take a step backwards in your, you can basically do an application level undo in the state. And you can keep trying it back and forth and back and forth and back and forth until you debug what the problem is. There are also other benefits to immutability. It can make things easier to reason about, even if you don't have time travel debugging. But that's where the idea for it came when Dan was creating the Redux architecture.
Cloudinary is the image backend for web and mobile development. As web and mobile development have become more about images, you might have found yourself frustrated, manipulating images, uploading images, trying to optimize their delivery in your website or in your mobile app. Cloudinary makes software development with images simple by combining the speed of a CDN with an API for tasks such as image manipulation, uploading, storing, facial recognition, and of course, fast delivery for any device. Software Engineering Daily loves showcasing products like Cloudinary because it is so focused. It provides a great experience both for developers and the end users of those developers' products. You can try Cloudinary's image manipulation easily by going to cloudinary.com. You can upload an image of a cat, for example, and resize it by simply changing the URL. Now that is a rich image API. Cloudinary is used by companies like Dropbox, Gizmodo, Fiverr, eBay, Lifehacker, many more. These companies obviously have tons of images and high demand for how they want to manipulate and serve their images. Cloudinary is also a proud sponsor of O'Reilly's 2016 Fluent Conference, which is March 8th through 10th in San Francisco. And Software Engineering Daily is giving away a free ticket to Fluent. To be entered into a drawing for this ticket, tweet at software_daily about your favorite episode or tell us why you love Cloudinary. Thanks again to Cloudinary. We are proud to have you as our newest sponsor. So, the third problem that Redux solves is that there are no good places for third-party plugins to jump in. How does Redux solve this problem?
So the way that the store is structured helps with this a lot. Now in Flux, like I said, there could be multiple stores. And these stores are just sending off notifications whenever they're done to anything that's subscribed to them. That gives you, that makes it so that you don't have a single point to capture all of these notifications. What the Redux structure does is it centralizes all of this. It basically, there's a single store. And so you can use what's called middleware to jump in into the process. And before the store sends the action down to the reducers, you can jump in. So this is really good for things like logging. If you need to send off a promise to update data, we were talking about persisting data. This is the place that Redux gives you to do that, is in middleware.
Perfect. So we've kind of backed into the finer points of Redux. Let's talk about the new characters that you introduce in your cartoons to represent Redux relative to Flux. So what are these new characters that you introduce? And maybe you could illustrate how the data flow in Redux works for us.
Sure. Well, so you start off with the view still. And the view does talk to the action creator still, so that telegraph operator. But instead of the action creator sending off the message to the dispatcher, the view will have passed in, will get the action back. And so the view is going to be the one that sends off that action, and it's going to send it directly to the store. The store has kind of done this little power grab and has become the dispatcher too. So the view sends the action that the action creator has created off to the store. And then the store is going to send that to the reducer. And I think of the reducer as kind of a department of, because you can actually you have a root reducer who's in charge of this department of reducers. And then you have all of the reducers under it that take care of changing little bits of the state. So you could have a reducer that just takes care of message, the messages that you create if you're building Facebook, and another reducer that just takes care of event invitations. So they break up the work between themselves. And each reducer, when it gets the data, because the store has sent the data down to the root reducer, the state, when the sub-reducers get that data, the little part that they care about, they're going to make a copy of it. They're really concerned about not screwing things up. So they're going to make a copy of it, make any changes, and then pass that copy back up to the root reducer, who will combine them all together to create the new state object. So then the store, the reducer gives that back to the store. The store has whatever the new state object should be. And it lets this new character, which is basically the view binding layer is what it's called. I liken it to an IT department that's in charge of making sure that the data is available for the UI. So this IT department, I drew it as Maurice Moss from the IT crowd in the cartoon, and a lot of people got a kick out of that. The view layer binding, that gets the state from the store and automatically provides it to all of the components in the system. So that's kind of neat because it cuts down on the boilerplate code that you need to have in your views and your UI.
So talk more about the advantages of Redux relative to Flux, because when Redux came out, it was kind of like a slow, but not that slow, I guess. But there's a pretty quick, I guess, uptake of Redux as kind of this is the way that you should do Flux. So what were the lessons from Redux that people appreciated so much about it that caused it to become the kind of de facto Flux implementation?
I think one of the things is that it can be more predictable because with the way that it works, these reducers are all doing the work. The store doesn't send out any notifications until all of the reducers are done with their work. So you just have one notification coming out of the store, as opposed to in Flux, you have a bunch of different notifications coming out from different stores, which can be harder to see what's going on. I think also the fact that it gives you that single extension point that for middleware to extend, that means that other developers can build on Redux in a way that you can't in Flux. Flux isn't really it's not really a library. It's just a pattern. And so it's harder for people to collaborate on these extensions.
So we've talked about Flux and Redux, which are data handling patterns to keep your user interface in sync. But there's still the question of how we get that data from a component to a server, or if we're trying to get data from a server to a component. And this is made possible with GraphQL and Relay. So in your cartoon, you draw GraphQL as a librarian. Could you explain how GraphQL works and why it's analogous to a librarian? Sure
thing. So GraphQL you can kind of think of it, it is like SQL in a way. It's a way of querying data, but unlike SQL, it doesn't actually store the data. Your GraphQL API just provides a mapping between whatever does store your data. It might be SQL, it might be a bunch of other web APIs, it might be MongoDB. It just gives a thin front end that your code in the browser can talk to. So GraphQL, basically, if you ask GraphQL, send me the user and the first 10 of their friends and all of the events that those 10 people are going to be going to in the next month. GraphQL knows how to turn that, the GraphQL server knows how to turn that into whatever queries it needs to get the data out of your database. And so you actually need to write the code for your GraphQL server that, does this mapping between whatever queries coming in from the client and whatever, different databases you have on your backend.
So Relay makes the connection between the graph that you have in the cloud and the graph that the user is interacting with on the page. And in your cartoon version of Relay, you have Relay as a bike messenger. So explain why Relay is a bike messenger.
Yeah, so the query system in Relay, I liken to a bike messenger because I think of bike messengers as being really obsessed with, speed and efficiency. And that's what the query system in Relay is really prioritizing. So Relay, one of the neat things about it is because you've described the graph that all of the components need, in Relay, you build up these things called fragments. And so each component knows which fragment it needs, which part of a graph it needs, what little bit of data it needs from the cloud. And because you know this, because you have this declarative description of the data that's needed for each component, it makes it really easy to optimize the queries. So when a query comes in, it gets sent from the UI to the store, and the store tells the query system, okay, I need this data. The query system does a double check, basically doesn't want to expend too much energy. So it will go back to the store and say, hey, do you actually have any of this data? If you have it, we don't need to get it. So the store and the query system will work together to see what data the store has. And the query system will take that out of the query. And then the query system will also look at any pending requests it has. If somebody else has already asked for, part of the graph, it will take that part of the graph out of the query as well, because it knows that part of the graph is going to be coming in soon. And so that's why I think of it as a bike messenger, because basically it's doing all it can to reduce the amount of work it does. And then it's going to go back and forth between the parts of the system that actually interact with the server and the store. It's going to ferry data between those two.
If Relay is the bike messenger and GraphQL is the librarian, how do these characters interact, and why is that analogous to the real world?
Well, it's actually, I have a fourth part in the series that's coming out on Wednesday.
Oh.
Which is going to go into exactly this, how all of these different parts of the system work together. Because one of the things I note in that fourth cartoon is that the cast of characters in Relay has kind of exploded. There are so many more parts of the system, and that's because Relay really is a framework, whereas Flux and Redux are patterns. Relay gives you a lot of functionality. It does a lot of things for you. It doesn't tell you how to do things. And so the Relay is actually, the query system is only part of it. There's also a mutation system, which I liken to an architect and a contractor. And there are a few other parts that you'll see in the fourth cartoon.
Can you give us a preview?
Sure. So one of my favorite parts is the network layer. And I liken that to the operator from the Matrix, because its job is to get queries into the cloud and get them out of the cloud. And so that's the one that actually is going to be working with this librarian. The network layer is going to be the one that's sending the requests to the GraphQL server and getting them back. So you could really think of the librarian as kind of like an Oracle type figure, I guess. But what Relay does is not exactly analogous to what Flux and Redux do. People call it basically a React for data. And that is, I think, a much closer description than a comparison to Flux and Redux. It makes things simple for the user by making things more complex within the framework.
Are people adopting like I hear a lot about a lot of adoption of Redux and React. I hear slower adoption of GraphQL and Relay. I think it's just, because there's a lot of stuff to take up. I don't think it's necessarily a criticism of them, but are people aggressively adopting these technologies?
I'd say that for a lot of use cases, Redux is actually a better solution. Relay does have a lot of adoption costs that go along with it. Things like building up your GraphQL server. And if you have the kind of application that Facebook has, that's worth it. Most applications are not Facebook, though. So unless you have a lot of API calls, you have a very chatty application that has to make a lot of calls back and forth from the server, and you have these big graphs of data, you're probably better off with something like Redux. So I think that's probably why you aren't seeing so much adoption of GraphQL and Relay, and they're also just newer. So I think that's a part of it too. There hasn't been too much documentation. They've done a good job of documenting it, but I think that the ecosystem needs to do more filling in the details.
Could you contrast Relay and Redux a little bit more? Maybe I'm still not quite getting the differences between the two.
Sure. So Redux, with Relay, one of the things that it does is it will take the data that comes in from the server and it will actually merge it into a graph structure. If you were doing this with Redux, you'd have to actually write this code yourself. It actually figures out, okay, I got these 3 new things from the cloud and these 3 new fields on things that I already have. And it will figure out how to actually handle this operation of merging in that data. And then the store automatically sets up observers. So it knows when it gets this new data from the cloud, it knows that it needs to update certain parts of the front end. So it doesn't necessarily need to go through a full re-render. It will actually notify certain subtrees, and those subtrees will re-render. But I'd say it's more just like it's creating this mapping between the graph in the cloud and graph in your browser, which Redux just doesn't even know about or care about.
So, you're talking about Relay as a solution for perhaps products on the scale of Facebook. Is there an easy migration path from somebody who starts on Redux and scales to a giant scale application where they would want to go to Relay?
Well, one of the nice things is that there is a thread that ties them all together. And that's the idea that you have these actions that are representing your state changes that you have in your system, all your interactions with your user. And so those you can keep. So a lot of that kind of stuff can easily just go straight from Redux to Relay. The major change that you'll have is one in these things called containers. You have to write containers that have the query that you need for each component. And 2, you need to write your GraphQL API. So those would be the 2 things that you need to change if you're going from a Redux-backed solution to a Relay-backed solution. But there's a lot that you can keep.
So as we've discussed, you're going to be speaking at O'Reilly's Fluent Conference, and you'll be giving a talk called A Cartoon Guide to the Wilds of Data Handling in React. So as we've discussed these different components of the React data handling stack, what are the high-level themes that we should keep in mind as we are developing our own data handling flows within React?
So I would say if you're developing your own, of course, one of the things in the React community is this open-mindedness to new solutions. So, of course, if you think that you have a new solution, you can give it a shot. But I personally think don't reinvent the wheel. Use one of the established solutions in your production apps for sure is my opinion. One thing I should be clear about is these are not the only established solutions. There's also things like Falcor, which I didn't actually draw any cartoons about, but people do use, like Netflix uses. But the common thread with all of these is this idea of declaring. Instead of having imperative changes, imperative interactions, basically making all of the interactions with the system declarative. That's one of the nice things that React has brought to front-end development is a emphasis on doing things declaratively. So I think if you're going to be building anything that requires data handling, having your actions actually be objects that represent that action is a really good thing.
What are the common misconceptions that people have about the Facebook stack of technologies?
I think that's one of the things that I really was interested in doing with code cartoons is addressing these misunderstandings. I think because people were so enthusiastic about it so quickly, a lot of people have gotten either yay or nay, have gotten really excited or really down on it without actually digging into the details of what things do. I actually, I worked at a place where I was working with some very prominent people in JavaScript, and one of the people was really down on virtual DOM, even though he didn't know the difference between the virtual DOM and shadow DOM. And I was thinking, it'd be really nice to have people really dig into the details before giving a critique of different technologies. So I think that's one of the things that I'd like to do is basically clear up misunderstandings. I think that these misunderstandings are in every part of the system, though, because so much writing about tech is cheerleading, is really being enthusiastic and throwing around words that don't necessarily mean the things that people think they mean. So
yeah, it's either cheerleading or it's like acerbic, overly hostile criticism.
Exactly.
It's hard to find the measured forms of analysis unless you look to cartoons.
Exactly. So hopefully that's something that I can help with, and hopefully it's something that people see as a viable way of talking about things, is just looking at them and not necessarily having strongly worded theses about why they're wonderful or horrible.
And you're working on a book for, I think it's, I forgot the title of it. It's like covering React.js with these code cartoons. What's the title of the book?
A cartoon guide to React.js. Yeah.
Right.
And
okay.
It's going to include things like Flux, Redux, Relay.
So what is the overall scope of the book? How it's interesting because when I talk to people who create educational materials, sometimes they find like they don't know how early in the world of programming to start. Like when I think about Cartoon Guide to React.js, you could start with MVC or you could start even earlier. And then it's like, how deep do you go? Do you start thinking about like what could potentially happen in the future? What is the scope of your book?
Yeah, that's been a really tough question for me to think about. I'm going to try to follow the same kind of path that a lot of intro books would cover, like code intro books, but not get into the code. For the code cartoons books, I really want to keep it at a higher level where you're looking at the architecture, you're looking at the concepts and not actually how you implement them in code. It's more of a supplement to things like, video tutorials and these other things that would show you exactly how to implement things. I plan to cover in the first part things like components, just the general idea of components in the virtual DOM, how the virtual DOM works. And then I'll probably also cover things like React Router, generally how you would test React applications, how you would handle CSS. And then the last part of the book will be dedicated to these data handling frameworks and patterns.
Yeah, I think this is such a great idea. Like I think about the XKCD guy, Randall Monroe. His books have been so successful, and they're They're perfect coffee table books. They're perfect books to read before you go to bed. And there's not a bevy of these types of books for programming concepts.
That's true. I actually, part of the inspiration for this was a series of books that I read when I was a kid called The Cartoon History of the Universe. And I would read those just, over and over again, right before bed and stuff like that. Because it was fun. I was learning, but it was also really, really fun to read them. And so I ended up having a really good understanding of history. I actually, there were a couple of questions on the AP exam, my senior year of high school, that I knew because I had been reading these cartoon guides to the cartoon history of the universe. So I am hoping that, these cartoon books basically give people the same thing with code, something that even kids maybe, the teenagers could be reading, and it's not taxing, but you're learning a lot.
So you work at Mozilla, and Mozilla is, of course, this revered open source. I mean, it's a business, obviously, but so much open source has come out of Mozilla. So from that point of view of being at Mozilla and understanding the open source perspective of Mozilla, what is it like to engage with the React community? That's also obviously an open source community, coming from a fairly different place, obviously a very positive, incredible project, but sort of a contrasting open source environment, I imagine.
I'd have to say, one of the big differences is that React has figured out how to use GitHub for their projects, whereas both Facebook and Mozilla actually use Mercurial as their version control for their software. But the React community has figured out how to manage having both Mercurial on their internal stuff and merge in things from the community using GitHub. I'd say that there isn't actually as much difference between the two as one might think. I think that a lot of the Facebook open source stuff isn't necessarily it's not as influenced by its affiliation with Facebook as you might think. Of course, it does affect their prioritization of things, but I'd say that you have the same thing with Mozilla. You have prioritization based on what our goals are. So I think that they're more similar than they are different.
Fascinating. Yeah, I did a show with the Ruby on Rails creator recently, and he was contrasting Rails with the Linux community, which sounded starkly different. So that was kind of the, where I was coming from with that question, what I was thinking about. But it's interesting. It sounds like there's more overlap. So what do you see as the future of React?
So, you know what? I don't know. It's so hard to tell. Because things do change so abruptly in front end. I think that the future of React is probably in the concepts it's introduced to the front end community and has popularized. I think that those concepts of having the UI be a function of the state instead of having things that are so imperative and so coupled. I think that is going to be what lasts, and the framework of React may or may not. Fascinating.
Well, Lin Clark, thanks for coming on to Software Engineering Daily. It's been great talking to you. I love code cartoons, and everyone should check it out, code-cartoons.com. And I'll see you at the O'Reilly Fluent Conference, and I'll have a shirt for you.
Oh, great. Thank you very much. It was a pleasure coming on.